Good afternoon, everybody, and welcome to this seminar on cloud computing and software engineering. See, today we know that cloud computing is a very great area to do many programming projects, and software engineering, you know, is a disciplined approach for developing an application. So in today's presentation, the purpose of this presentation is to tell you that cloud computing represents at the same time a new emerging opportunity and a new challenge. New emerging opportunity because it is happening in our generation and it's one of the boon that we have got. It is a new challenge because it is posing many challenges which earlier were not available or earlier programmers did not face. So this presentation aims at identifying the challenges which is inherent to cloud computing application and suggest some approaches towards that. See, the agenda for today's presentation is just I will tell you to begin with what is cloud application and how does it differ from the traditional application. And secondly, cloud resources which are there available for developing an application. My students over a period of last 3-4 years have developed many cloud applications. Then I will show you to them. And then I will give you some general examples. Before we get into the cloud computing area, let us trace out the history of cloud computing and how applications have developed over a period of time. So, first kind of application that happened in 1970s were called desktop application. And if you can see from this picture, in desktop application you have a computer in the center and you have business logic. Business logic is your application which is installed onto that hardware and your data. So, for example, if you are using a Windows application, the Windows operating system, then you installed your Microsoft Office as an application, then you have created your document. So your computer, your hardware, your application, your installation and your data, they all stay on your single machine. And such an application is called desktop application. In a desktop application, you have full control and ownership of the machine and data and software. So it's your machine, your data, your application. So in the 90s, we had a second kind of application called web application. So look at here. There is a difference. Now actually on the right side there is an application and which is connected to you through a computer, but your data and business logic are on the internet or the web application. For example, you look at an application like Indian Railways reservation system, where actually we use your computer only to get connected to a railway server. So that means the business logic or application is residing on the server of the Indian Railways. Then you have to try to book a ticket. So vacancies are available in a particular train. The data is again available on the web server. You see it on the left side. And whenever you book a ticket, and all the information is also stored on the server. So your machine is only used for connecting to their server and started using. So this is in contrast with the desktop application, where in desktop application everything you have on your computer. Now here you have only connection on your computer, nothing else. So no ownership and data is stored elsewhere, and applications come from the server provider. And whenever an application comes from the server provider, it is normally a very slow experience. Now we have this cloud computing application. Look at this. There is a great difference in this. Unlike in the previous picture, we have a cloud on the left side and your data stored on that. The application actually is not downloaded onto you, or it actually has nothing to do with your machine. So you just get connected to that through your browser and you start using that. And where is the business logic? So business logic is in your browser. So whenever you start using an application, your browser will require, will copy or whatever that is needed to run that application, and hence it will run that. So application is always very thin. So your browser will understand whatever that you are doing at current moment of the time, and then that will do it. So in cloud application, your data is stored somewhere on the Google server kind of a thing, and your application is somewhere on the cloud, but business logic is transferred to your content. So now these applications are very rich. So if you see any cloud application like Google application, Gmail and all, you have many features. And it is remote because it is not installed on your machine, and very responsive. Now whether you are using Gmail either from your laptop or from your cell or any other device, you don't find any degradation in the service. So the objective of cloud application, why people are developing cloud application is simple. Cloud application represents state of the art. So today if you want to develop an application, it has to be a cloud application. They try to combine the best of both worlds, richness of a desktop. See what it means is, suppose you are using a desktop computer, then since you are completely control of that, you will have a rich, rich set of features and all. So cloud computing would like to emulate that. and remoteness of web application. But we want to achieve this by not insisting you to install your application on your machine. It has to come from a remote server. So what does a cloud application mean? So in cloud computing, applications are the application available over software as a service over the net. So any application in cloud means it is a SaaS application, which facilitates the user to run application without installing them. So one of the fundamental features of cloud application is it should not ask a user to install it. Compare this with your Android application. Every time actually you have an application, you have to download it, whether you are using it on a mobile or not. So in contrast, cloud computing doesn't ask you to install. Hence, it will not use any resource on your machine. So by doing this, this will save the cost of infrastructure and hardware. So that means it doesn't take your memory space. It doesn't ask you to add additional hard disk and so on and so forth. In general, cloud computing do not own the infrastructure. They are given the infrastructure, and third-party providers as a service, for example, Gmail or any other application. So what is the meaning of cloud application? Cloud application can be used without installing using a browser. So where do they come from? See, all these leading cloud service providers, they have something called data centers. And data center is a place where they have big infrastructure in terms of computers, operating systems, applications, and telecommunications. So whenever you try to link an application through your browser, it is transferred to your network. So every user will have a unique account. For example, Gmail, you have to enter your first name, password, and other things so that you can access them. So any simple example of cloud application, here is an application called Cloud App. So what it does is actually it will allow you to upload your file and share with the rest of the world. So the reason why I'm showing this application is very simple. It shows how simple idea can be a big cloud application. All this application does is just upload your, allow you to upload your file and share it across the population. You may wonder who will do this. See, there are certain applications like, for example, if I are running a college like ours, then many a times you can upload your brochure and they actually give access to any prospective customer. So instead of printing a browser which is expensive in terms of printing colors and all, you can actually allow your people, your custom prospective parents and students to see them directly from the cloud. So at this point, I want to open for question. Any questions, Sridhar? Sridhar, any questions?
Not yet, sir.
Hello, Sridhar.
No questions yet, sir.
Okay, so I'll move on. So now, before you develop a cloud computing application, you must also, first thing that you have to do is to find the difference between existing applications and cloud computing. There are different, so much so that actually cloud application is a different world order. So in first quality of cloud application is statelessness. What it actually means is whenever you use a browser and touch Google application, it will serve you and forget you. It will not remember you anything. Of course, there are cookies which will save some transaction, but that is not part of the server. So statelessness application means an application will respond to your request and forgets you. So the big difference between traditional application and cloud application is that cloud application itself is able to make the provisions. Say for example, when you are developing an Oracle application on your desktop or your server, then you also find out how much hard disk is required, how much RAM is required, how much devices are required. So this kind of a thing is not there in cloud computing. You just develop an application, the third party will actually give whatever the resource that you need. The second difference is actually cloud application, if you want to be successful, must be stateless, like Gmail is a stateless application. So if cloud computing application has any state means actually nothing but saving certain parameters or some data during the execution of application. If it is to be there, then actually you have to convert them to the extent possible that they are stateless. So there is no concept of local disk, there is no concept of registry. Hence, you don't have to assume anything when you are running a cloud application. Maybe first 10 minutes your application will be run on a particular server, say a Google server in Scotland. For next 20 minutes it may be run using a Tokyo server. So you don't have to accept any state. If you accept a state, then you have to carry the content. That is not possible in cloud computing. Secondly, cloud computing application need to be designed for redundancy. What it actually means is, since cloud computing uses many ordinary or what you call commodity hardware, so it is the chances, the theoretical chances of any hard disk going wrong or any hard disk breaking down is very high. So when you are developing an application in cloud computing, you should always assume that the hard disk that you are trying to save is actually may get crashed. So, and you should acknowledge it. So it is a guarantee that machines are going to fail. Hence your application, if it ends up with some hard disk which is crashed, then it should automatically recover itself and go to another hard disk or another storage device. And secondly, unlike in our traditional application, whereas actually you will install your machine, your application on your server, data is also stored on that server, and all the relevant information or parameters stored. In cloud computing, that's not going to happen. So applications may be scattered in many places. For example, suppose you are using a Facebook application. Presentation layer of Facebook may be stored on Facebook. For example, you log in and get into Facebook. So that may be coming from a Facebook server. But the content, the photos that you store, the video that you have stored may be actually stored on Amazon's S3. That is a different computer company again. And application logs could be somewhere else. For example, if you are playing a game, which is a third party on Facebook, and that logic of that game actually is coming from another server which only the company knows that. So the first thing that you should know in cloud computing is a cloud application components of the application may be staying in different machines, in fact different continents altogether. Whereas in traditional computing, entire application is to be built on your own server. So for example, if you put your server on, then the application is working. If the server is down, nothing is going to happen. So building a cloud application requires a solid engineering design, because now, as you see in the earlier slides, you cannot assume the local disk, you cannot assume a local machine, you cannot assume a particular operating system, and in this case, you may not assume every So developers need to keep in mind the difference between cloud platforms licensing models and different cloud models. For example, in a traditional computing model, we used to buy Microsoft Office for 3,000 rupees, right? Then get it installed. So after that, it is your machine and your application. Whereas in cloud computing, installation is not possible, so that a developer cannot sell his software unless he gives you some kind of a soft code for it. So what this is actually, so this has made cloud developers to develop a different kind of a licensing model where everything is subscription based. That means instead of buying a Microsoft Office for 3,000 rupees, what you say is, I am going to use your software for say 3 weeks or 3 months, so that they will charge like a magazine subscription. So you will subscribe a magazine for 3 months, 1 year, or so on and so forth. Similarly, suppose you are running an organization. So instead of buying 10 copies of Microsoft Word or 10 copies of Oracle installation for your employees or your developers, you will buy 10 user license. That means Microsoft Office will say that if I license this for 10 users, 10 of your employees can use in this organization. Similarly, if I license my Oracle to your organization, 10 developers can use that. So there is a fundamental difference even in selling and buying cloud computing applications. So in the old world, actually you bought them. Today you are actually licensing them or subscribing them. And the third and the the next important thing that you have to do is, whenever you are developing an application on the cloud platform, we should always think of moving it from the existing platform to next platform. What it actually means is, in traditional computing, you are developing an application, for example, on a Windows platform. So if you wanted to work on say Android platform or say on Linux platform, it is not possible. You have to start from the scratch, code it again and do it. So that migration took a lot of effort. Whereas in cloud computing, that is not there. I already told you. So for that reason, whenever you are developing an application, it should be immune from any eventual environment it is going to run. It should work on Linux as much as it should work on a Windows. So for example, Google enables mobility by supporting what is known as Python language. Python is actually a kind of a platform neutral language. It works on many platforms. So if you write a program on Python, it is not restricted to either to a Google or to somebody else. It is not a proprietary. So the fundamental difference is you should develop an application and you should be in a position to pack it up to from say Windows to Linux to any other application platform. So that's the first thing that you should remember. Now that I have told you the differences, now I'll come to what is the software engineering. So software engineering is an application of systematic, disciplined, quantifiable approach to the development of operation and maintenance of software. In the traditional world, we have this SDLC and we have this waterfall model or spiral model or what we call prototype model. So the same thing works in cloud computing, but in a different world altogether. Cloud computing offers new possibilities for multilateral software. The key line here is actually multilateral software. What it means is, in traditional computing, suppose you are using a Microsoft Office on your machine, you are the only one user. Whereas in cloud computing, if somebody is using Gmail, then thousands of people are using that. So you cannot continue with your traditional model and start operating in cloud computing. So for that reason, as I said in my earlier presentation and all, cloud computing companies use what is known as multi-tenancy. Multi-tenancy is one application running on one server but serving multiple customers. That means every time I am using a Gmail and my friend is using a Gmail, it is not 2 copies of Gmail that is actually in action. It is 1 copy for multiple clients. So this kind of programming or a development approach where one application can be used by multiple users called multi-tenancy. Okay, the research I told you, probably you have seen, remember my my slides on multilateral. See, now I told you in traditional cloud computing, in traditional computing, we were developing application on a very solid single user platform, whereas in cloud computing, it has to happen on multiple operating systems and multiple users and all. So one of the great challenges that they are facing is in terms of what is known as load balancing. Say, for example, if your application is running and somebody is using it in Australia, and suppose you have stored a data, say in America, and how do you ensure that the speed of the networks will ensure the data transfer in time and timely manner? So load balancing is one challenge, and another one is actually the transportability between 2 or 3 databases. See, when you have huge data, then you don't have schema, and we have a very unstructured data. How do you actually collect that data and manage when there is no relationship, there is no primary key and all? So this is the second challenge. Totally, there are actually 10 challenges for cloud developers, and those challenges actually are on the slides next to this summary. But now that there is no time, I'm not showing you. But in case somebody is interested, let him shoot me an email. I will send this entire deck presentation.
How is data stored at the portals of CSP?
Okay, CSP stands for Computer Service Provider. Okay, sir. And depending on I told you, every CS provider, service provider, they will have their own data centers. For example, Google has data center, Microsoft has data center. So the data is stored, like see, the moment you log into Gmail, they will collect your whatever the data and they store it in data center. And depending on the kind of the data, for example, if you have a Google Doc, then they will store it as a document. And suppose you have uploaded an image on Facebook, they will store it as an image. So they will have hard disks in their data centers. They will store according to the Gmail ID that you have given. And whenever your user want it, it will be transferred to you. For example, when you download to your machine, what has actually happened? Your data stored in a data center in Google data center is downloaded to your laptop or your cell. And when you upload, that goes to data center. Yeah, next question, sir.
What is the difference between message passing interface and MapReduce paradigm?
So they are totally different, sir. Actually, message is actually something to do with communication. Okay. So communication, and MapReduce is altogether different algorithm for handling distributed computing tasks. Message passing interface would mean, see, for example, suppose you are trying to log into Gmail. So what are you doing? Actually, you are giving your name and the password. So this is actually you are passing the message about the credentials of a user to the server. So this is called message passing. And that has nothing to do with MapReduce. It's a totally different thing. So next question.
Thank you, sir. Those are all the questions.
Okay, thank you, sir. I hope it was interesting. Thank you, sir.
Thank you very much, sir.